This video was possible with the help of the Wolf of YouTube. Enjoy!
October the 15th, 1962. The first day in a two-week crisis that brought the world closer than it has ever been to all-out nuclear war. This was the day that US reconnaissance photographs revealed Russian medium-range missile sites in Cuba. If these installations were operational, nearly every city in America would be within range of Soviet nuclear attack. President Kennedy and his military advisors agonized over the best course of action. With US forces ready to invade the island, superpower tension reached an all-time high. In Britain, the V-Force nuclear deterrent's well-practiced procedures were swinging into action. Bomber bases were sealed off by armed patrols and put on maximum alert. Hydrogen bombs were transported to the RAF stations from the top-secret storage facility at Foldingworth, north of Lincoln. As the crisis deepened, the Vulcan, Victor and Valiant V bombers were armed and stood combat-ready. Just over 1,000 miles to the east, Soviet medium and intermediate ballistic missiles were being prepared for launch. Reaching a speed of Mach 4, these missiles could strike V bomber bases in as little as 15 minutes. Britain's early warning radar would have detected an attack a mere 4 minutes before UK targets would have been hit. To increase their chances of being far enough away from the nuclear blast to survive, V-bombers were equipped with a mass rapid startup facility where all 4 engines and electrical avionics would come to life almost instantly by pressing a single button in the cockpit. This allowed a scramble takeoff in just under 2 minutes. By Friday, October the 26th, 1962, aircrew were camped in caravans next to their aircraft, poised for the alert klaxon. In 1945, the new Labour Prime Minister Clement Attlee knew full well that the bombs dropped on Hiroshima and Nagasaki had changed the world. Within weeks of the attack, Attlee had concluded that in the face of such awesome destructive power, the provision of air raid precautions and shelters would be futile. The answer, he felt, to an atomic bomb dropped on London would be dropping an atomic bomb on the enemy's greatest city. How Britain was going to acquire the means to retaliate was another question there. In the aftermath of World War II, the country's economy was stretched to the limits. On top of this, less than a year later, the US Congress passed the McMahon Act. This forbade the disclosure of nuclear information to any foreign power. Even former A-bomb collaborators, Britain and Canada, were denied access. If Britain was to have defensive atomic weapons, it was clear it would have to design, test and build them on its own.
I think it was important that we had our own independent deterrent. We were well aware that Russia was just over the horizon. Stalin was still there, and his avowed intent was, in fact, to spread communism.
By January 1947, Attlee authorized the manufacture of a British bomb. Without America's industrial know-how, this was going to be a costly and difficult process. Added to this would be the expense of developing a whole new generation of jet bombers needed to deliver the British weapon. Whilst the RAF had squadrons of advanced fighters, larger jet aircraft were still years away. Undaunted, the Air Ministry drew up the specifications for a strategic jet bomber. It called for a fast, high-altitude medium bomber for the purpose of long-range conventional and nuclear strikes. 3 separate British aircraft manufacturers, Vickers-Armstrong, A.V. Rowe and Handley Page, undertook the task of designing and building aircraft that would meet these requirements. The result would be aircraft that would set new standards in aviation design, manufacture and performance. The V-bombers. The first V-bomber to be completed was the Vickers Valiant. A comparatively simple design, the development process of this aeroplane had been very rapid. It bridged the gap between old piston-powered technology and the more revolutionary schemes that Avro and Handley Page were working on. At the time, this suited the defence planners very well, as the first British atom bomb was now well on the way. The Vickers design team had developed a long-range bomber which incorporated advanced design features, including power-assisted flight controls and swept-back wings mounted on the shoulder of the fuselage, allowing room for a sizable bomb bay. With its maximum ceiling of 54,000 feet and high speed of 554 miles per hour, no defensive armament was considered necessary. The Valiant made its maiden flight in 1951 and became the RAF's first nuclear bomber when Britain's A-bombs were brought into service 4 years later.
Our world status was definitely raised. America had the bomb, we had the bomb, Russia had the bomb, and that was really it at the time. So it meant we were a big player in the world.
By this time, though, the Americans had successfully tested a new type of weapon that took mass destruction to a whole new level. The hydrogen bomb. The thermonuclear technology it used led to a device hundreds of times more powerful than any atomic bomb.
President Truman's momentous decision to make the hydrogen bomb rocks the world. The news is blacked out behind the Iron Curtain, but in the United States, headlines from coast to coast carry the president's announcement.
Shortly afterwards, the Soviets followed suit. It was clear that if Britain wanted a credible, independent deterrent, it would now need to produce its own H-bomb. The British government were determined to be regarded as a serious nuclear player. They were also hoping that membership of the H-bomb club would lead to the future restoration of Anglo-American collaboration on nuclear weapons.
But for the deterrent of the atomic bomb, it is certain that Europe would have been communized like Czechoslovakia and London under bombardment some time ago. But for the deterrent...
Back in power in the early 50s, Winston Churchill authorized scientists at the Aldermaston Atomic Weapons Establishment to set to work. In November 1957, the result was ready for testing. That month, a Valiant released a 1 megaton thermonuclear device over Christmas Island in the South Pacific. The Valiant was followed into service by the remarkably advanced Avro Vulcan. The designer of the Lancaster, Roy Chadwick, was working on the design of a 100-foot span delta as early as 1947. Inspired by German wartime experiments, he envisaged an aeroplane that would have a sufficiently thick wing to house fuel and engines. A slight bulge in the midsection would accommodate the cockpit and bombs. Its delta wing configuration promised significant advantages. Huge storage capacity in the inboard section of the wing, allowing for powerful engines, and good handling characteristics at both ends of the speed range.
In this tunnel, speeds up to Mach 1.6 can be reached, and Avros are now building a third wind tunnel for research into Mach numbers as high as 3.5.
This was groundbreaking aerodynamics, though, and before the prototype could be designed, a number of experimental 1/3 scale delta-winged aircraft would have to be test-flown.
It was at this stage, early in 1950, that Mr. Rowley Falk joined the company. Mr. Falk probably knows more about delta-wing aircraft than any other pilot. He began development flights at a crucial stage. It was the first time any delta-wing aircraft had flown in Britain, and it aroused great curiosity, which wasn't entirely confined to the aeronautical profession.
The first Vulcan flew from here, piloted by our chief superintendent, he was of test flying, Rowley Falk. He came out of the building here, pointed over to the flight sheds, taxied down the runway, turned it round, did all his checks.
698, takeoff. 698, Woodford Tower, cleared for takeoff.
Came by halfway down the runway, it was airborne. It was airborne for 2¼ hours. It stopped the whole of Cheshire, the traffic, everything, ground to a standstill, because he'd never seen anything like this at all. He thought it was on the amount of space. He really was terrific. It was a terrific day in aviation.
The remarkable qualities of this design soon became apparent.
The manoeuvrability of the airplane was quite remarkable. The great wing area meant that at high altitude, the airplane was still extremely maneuverable, and when set against the fighters of the day, such as the Lightning, we could easily outturn the fighters without any trouble at all. He only, of course, has little wings that are highly loaded and is less able to turn in the thin air of more than 40,000 feet. If one compares the maneuverability of the Vulcan with other bombers such as the American ones, perhaps the B-52, there is just no comparison at all. The Vulcan had almost fighter-style performance and turn radius, which was quite sparkling by the standards of the day.
It came over the new assembly, that's the name of our workshops here at Woodford, and he rolled it like a fighter. We couldn't believe it, that such a massive aircraft could be rolled, and he smashed all the glass in the roof of the new assembly, and it was like that for a long time, all taped up, till the roof was redone. I've never forgot that, and even the crowd that was here and all the workforce thought it was terrific.
Each aircraft is built up from over 100,000 separate parts.
The first production Mark Is were delivered in July 1956. This was to be the world's first delta-wing jet bomber. As well as a high degree of maneuverability, the Vulcan showed an exceptional rate of climb and descent. It could lose 20,000 feet in 90 seconds flat and recover to level flight in only 1,500 feet.
Enemy pointers. Safe storage. 1 bay fuel pump.
The crew of 5 were accommodated in a double-deck pressurized compartment. Pilots sat side by side on ejection seats, while the 2 navigators and air electronics officer faced backwards below and behind them. An enduring fault of the Vulcan was that in any emergency, the 3 rear crew would have to clamber through a hatch in the floor. Few escaped from the accidents during the Vulcan's development. The 3rd strategic bomber delivered to the RAF was the Handley Page Victor.
As the Handley Page Victor takes the air, we see a new shape rise in the sky. At all speeds near the ground, the crescent-winged aircraft controls easily enough to please the most exacting pilots. Notice the dive brakes, which on the Victor control the glide path without any change of trim. And now the Victor comes into land, and one of its most important features comes into play. With hands off the controls, the pilot brings it in on the approach. It flattens out and lands without the pilot touching the controls. An amazing and almost unbelievable characteristic of this crescent-winged aircraft.
The wing joined the fuselage well forward, allowing the weapons bay to be completely unobstructed. This took up most of the fuselage and was almost twice the size of the Vulcan's. As an alternative to the projected 10,000-pound nuclear weapon, it could carry 35 1,000-pound bombs, as opposed to the Vulcan's 21. The Handley Page design team had also used some revolutionary construction methods. Most of the structure utilized the new technique of bonding 2 sheets on either side of a metal honeycomb core. This metal sandwich was extremely strong and light, and also gave very smooth external surfaces, reducing drag. The Victor became the largest aircraft in the world to break the sound barrier. Like the Avro Vulcan, the Victor was found to be capable of performance and aerobatics that belied its size. At Farnborough, it performed slow rolls and loops. Avro and Handley Page always thought there'd be a fly-off between the Vulcan and the Victor. This led to intense competition between the 2 companies. Both aeronautical firms could ill afford to lose the production contract. Although the Vulcan and Victor were totally different aircraft, the RAF was never able to choose between them, and both aircraft went on to have long and distinguished careers in the service. With V-bombers coming on stream in significant numbers, Harold Macmillan became the first fully thermonuclear-armed Prime Minister. The early 60s were to be an extremely dangerous period for the whole planet. For the first time, the collective US and Soviet nuclear arsenal had the explosive potential to wipe out life on Earth. And the events that could trigger this nuclear Armageddon seem to be occurring with increasing frequency. The RAF was rapidly approaching the peak in its potency. Each bomber carried a single H-bomb with the yield of 1 megaton. The equivalent amount of TNT loaded on a goods train traveling at 50 miles per hour would take 6 hours to pass by. Bomber Command, with its force of 140 aircraft, now had the potential striking power of millions of World War II Lancasters. What wasn't fully appreciated by the British defense planners, though, was the pace of technological advance that Soviets would achieve in their missile design and construction. Unexpectedly rapid breakthroughs in solid rocket motors and the development of miniaturized components for guidance systems and warheads were beginning to make the V-Force's free-fall bomb system look increasingly out of date. And most worryingly of all, the numbers of surface-to-air missiles that could reach high-altitude bombers were rising all the time. It was clear the V-Force would have to modify its tactics if it was going to continue to be able to penetrate these defenses. An air-launched missile that could be fired at the target from a safer range looked like an answer. In the late 50s, work started on a standoff bomb project codenamed Blue Steel. This weapon, to be carried by Vulcans and Victors, could be launched 100 miles away from the target. At 35 feet long, it was as large as a fighter and would require considerable modification to both aircraft. When launched, its advanced onboard computer that was impervious to enemy jamming would fly the missile on a predetermined flight path to the aiming point. Within a specified range, a second rocket engine would fire, increasing the projectile speed to Mach 3. Once over the target, the engine would cut, and Blue Steel, with its 1 megaton warhead, would descend and detonate. Meanwhile, the Americans, with their massive force of B-52s, had the same need.
On January 5th, a major milestone was marked with the rollout of the first production B-52H. This model bomber is being factory produced as a Skybolt carrier.
The US solution was the more ambitious air-launched system, Skybolt. This weapon was intended to have a range of 1,150 miles. That would allow a bomber to fire the missile without even entering enemy airspace. With the British H-bomb tests and Macmillan's tenacious diplomacy, the Americans were persuaded to resume the special relationship between the two nations, and several Vulcans were adapted to take the new US weapon. With Skybolt being significantly smaller than Blue Steel, Vulcans would be able to carry one missile under each wing. The Skybolt program, though, was to be dogged with technical problems, and failing to perform in tests was finally cancelled by US Congress in 1962. With Blue Steel still being perfected, the looming Cuban crisis would test the V-Force to its limits. The recent success of Sputnik had stepped up the pace of superpower missile development and the arms race in general. The nuclear test program of both nations was proceeding at a frantic pace, leading to international fears about the effect of this saber-rattling. Against this volatile background, the Soviets shot down an American U-2 spy plane in May 1960. The following year, in response to the West refusing to withdraw their armed forces from Berlin, the Warsaw Pact built the Berlin Wall. The readiness of the V-Force was constantly tested.
Temperature selector, normal. Temperature control. control switch.
When we were scrambled, there were occasions that we didn't know whether it was the real thing or not. Very often we would be asleep and came the call over the tannoy and we would sprint for the aircraft. And the aircraft was always prepared carefully by us before we went. In other words, all your straps were laid out. You had your helmet plugged in and ready to go. And you had a strict drill, which we practiced a lot, to get on board in the right order, start the engines, throttles open, and away.
In the autumn of 1961, the Soviets shattered a recently agreed testing moratorium with the detonation of a monster H-bomb. To this day, its colossal yield of 57 megatons has never been exceeded. In response, the Americans immediately resumed their testing program with an extensive series of high-profile thermonuclear shots. The uneasy peace between East and West had never looked so shaky. Far worse was still to come, though. On Monday, October the 15th, 1962, an American U-2 photographed SS-4 nuclear missile launching sites in Cuba, a mere 90 miles from the coast of Florida. President Kennedy was informed the following morning and assembled his military advisors. Most of them recommended an airstrike to take out the Cuban bases, followed by an invasion. Kennedy immediately mobilized a vast army of men and material. The invasion plan called for the largest drop of paratroopers since D-Day. Strategic Air Command's fleet of well over 1,000 B-52 and B-47 bombers stood at DEFCON 2, the highest military alert short of all-out war. An eighth of these bombers were armed and in the air at all times, prepared to drop nuclear weapons on targets in Cuba and the Soviet Union. Pre-launch procedures were underway for the 172 intercontinental ballistic missiles ranged against the Russians. More than 100,000 combat-ready infantrymen were deployed to ports along the East Coast. And a huge Navy fleet, moments away from battle stations, was steaming through the international waters of the Caribbean. The American war machine was at its highest state of readiness, only awaiting the go signal from the White House. The Pentagon estimated that 18,500 Americans would be killed or wounded in the first 10 days of the battle. This influenced Kennedy's decision to forego an airstrike. Instead, the Americans imposed a blockade encircling the island. The dangerousness of the situation was exacerbated by primitive international telecommunications. Khrushchev was unable to gain instant contact with his commanders in Cuba. Commanders that, unbeknown to the Americans, controlled tactical nuclear weapons that they were authorized to use if US forces invaded. The famous hotline directly linking the two superpower leaders was still a year away, preventing the possibility of direct dialogue between them. The line between London and Washington, though, was in frequent use as the Prime Minister urged the Americans to exercise restraint.
This is the destructive power we pray God we will never be called upon to hurl at any nation. But should it become necessary, let us not hesitate because it is foreign to our nature to use the power which has been given us.
Harold Macmillan, as he reflected later, was about to have the worst few days of his life. Events that would come back to him as recurring nightmares in later years. He was in charge of Britain's thermonuclear bombers and ordered them to Alert Condition 3, fully armed and at 15-minute readiness. He was determined not to give the order to go to Condition 2. This would have meant the disbursement of the H-bomb armed V-force to bases all over the British Isles. An act, it was thought, that would send out dangerous signals about Britain's preparations for an attack. As the crisis approached its climax during the last weekend in October, contingency arrangements were made to transport Macmillan and his war cabinet away from London to Turnstile. This was the code name given to the top-secret World War III bunker 250 feet below Corsham in Wiltshire. A special train would whisk ministers and military top brass away from Paddington Station on the Western Main Line. Just before Bath, the train would branch off into a tunnel that led straight to an underground station in the bunker. After a short walk along tunnels cut through the limestone, the War Cabinet would enter the operations room. It is from here, with Soviet missiles only minutes away, that the Prime Minister would have ordered Alert Condition 1. This called for the annihilation of 30 to 40 Soviet cities with an assumed casualty figure of at least 16 million. Big cities like Moscow and Leningrad would get 2 or 3 H-bombs each.
Safe outside, one bay fuel pump.
Coming on.
As the V-bombers climbed eastward at full power, their crews would each have an all-too vivid idea of what was about to happen to their families and ground staff on the bomber bases they'd left behind. An hour after takeoff, the V-bombers would be at 56,000 feet over the Baltic, approaching their start lines, the designated position and time for the start of the attack.
It's important that all the attacks are coordinated. You don't want to be going through somebody else's bomb blast, for instance, so they have to be coordinated. I think we'd all been very frightened, that's for sure, but nevertheless, I'm sure we would have done it.
From here, they would fly carefully pre-planned routes contrived to avoid Soviet defenses for the longest possible time. At predetermined positions over Soviet territory, radar jamming electronic countermeasures would be activated. The ECM was very advanced for the time. The previous year, V-bombers had easily got through American defenses in a NATO training exercise. It worked by emitting radio interference or noise designed to jam Soviet radar. At that time, the Soviets placed great emphasis on controlling their fighter operations rigidly from the ground. Their pilots were instructed where to go, when to change height, and when to fire. So blacking out the ground radar stations was an effective defensive tactic. Soviet controllers would attempt to position a fighter no more than 5 miles behind the bomber, allowing the pilot to make visual contact. 4 VHF channels were used to communicate with fighter aircraft. V-bombers were equipped with a jammer that transmitted a high-pitched screech on those frequencies. In spite of these defenses, some fighters would inevitably get through. The V-bomber crews then had to rely on maneuvers to try to avoid being shot down. The Vulcan in particular was very adept at this. In the very thin air at high altitude, its large wings were still extremely efficient, allowing it to outturn any attacking fighter. If air-to-air missiles were fired, the final resort would be to release bundles of tiny foil strips. This would confuse the fighter's radar guidance system. Those V-bombers that survived fighter interception would then enter missile-controlled sectors. With Blue Steel still not ready, the bombers were equipped only with free-fall Yellow Sun H-bombs and would have to fly all the way to their targets, right through these SAM zones. Crews were briefed on the location of most surface-to-air missile sites, but there would have been too many to avoid them all. Radar detection equipment on board the aircraft would indicate when radars were scanning in their direction. When these signals were detected, the air electronics officer would try to jam the missile radar and feed it false targets while the pilot conducted evasive maneuvers. The main Soviet SAM missile needed 60 seconds of unjammed data to lock on. The V-bombers that successfully penetrated these defenses would now have split up to fly towards their respective targets. At 60 miles from weapons release, navigation and bombing computers would be updated by the radar operator, who would now be able to see the aiming point on his screen.
When we got near our target, we'd start our bombing run on the specific heading. It would be a radar run. The bomb aimer would then take over on the autopilot, and we'd zip down all these blinds over every window in the aircraft so that we wouldn't get blinded by the flash.
2 miles short of the target, bomb doors would automatically open. The city directly below was about to befall the terrible fate experienced by London, Manchester and Glasgow a couple of hours before. In an instant, the temperature at ground zero would have risen to 1 million degrees centigrade. A crater of a mile wide and 150 feet deep would have been gouged out. Underneath the 2-mile-wide fireball, all structures and anybody in them would have been vaporized. And buildings 7 miles from the center of the burst would have been reduced to rubble by the blast wave. The bomber had just over 1 minute to get clear. The escape maneuver employed was aerobatic. To slack a turn would be useless, as all anti-blast measures required the aircraft to be tail on to the explosion. After this, crews were expected to try to get home. They were even given return routes that were every bit as detailed as the outbound legs.
It was never planned to be a one-way mission. The object was always to get back to base if possible, because we might have to be rearmed and might have to make a second strike.
Had this unthinkable scenario ever become a reality, however, there would have been little or nothing for the bomber crews to return to.
We were well aware of the effects that our weapons would have on the targets, and also the effect that the enemy's weapons would have back home. And certainly we were fairly pessimistic about having anywhere to land when we came back, or even having a country to come back to. But you get used to all sorts of things. Yeah.
By lunchtime, Sunday the 29th of October 1962, the world stepped back from the brink of a nuclear holocaust. Khrushchev promised that the missile bases in Cuba would be dismantled. In return, the Americans assured the Soviets that they would not invade the island. In a further deal, US medium-range missiles stationed in Turkey, only 150 miles from the Soviet border, were discreetly removed. With that, the most dangerous episode in the history of humankind had come to an end.
I think that the V-Force really did help to keep the peace. I don't think anyone can deny that the deterrent worked. The tripwire philosophy, where if Russia attacked, we would go all out, I think was a big deterrent.
At the time of the Cuban Missile Crisis, the RAF's Bomber Command had aircraft at the cutting edge of technology, operated by a highly trained elite fully capable of penetrating Soviet defenses. Britain's close proximity to the USSR meant these V-bombers would have been in the first retaliatory strikes on Russian targets. Fortunately for the world, Khrushchev backed down over Cuba at the 11th hour. Perhaps the presence of the V-Force played some part in his decision.